I wanted to walk you guys through the velocity and acceleration lab. So I'm going to show you how to get to it. So I'm going to go to course materials, content, and then one-dimensional kinematics. I'm going to click on that first link. And then I'm going to search this sidebar, and I'm just going to look at the sidebar until I find the velocity lab. Here we go. So I'm
Now
going to
that you
download it.
learned the kinematic equations, we have to be able to apply the kinematic.
Okay, and it's going to show up down here in Chrome and also in my downloads folder. So I'm just going to launch it. Okay, once it's launched, I'm going to close this because I don't need this window anymore. I'm going to keep my calculator. And then I'm going to go ahead and I'm going to go to this moving man simulation. Okay, the first thing I want to do is I want to download this. Okay, and then the file will show up in my download folder, and so I'm going to click on it. It says it can't be opened because it's from an unidentified developer, but that's okay. I'm going to go to my system preferences and my security. If you don't have a Mac, it might look different on yours. And then I'm going to say that I want to open it anyway. Okay, so now it's starting. Okay, so here's my moving man simulation. Okay, and I'm going to go ahead and I'm going to look at the simulation. It says I need to make Java and Shockwave on my computer. It needs to be the latest version. And then I'll test values of velocity. And then I'll need to show my calculations for displacement in the space provided. Okay. So the first thing I want to do is I'm just going to do some different trials. Okay, so I can pretty much pick whatever I want. Okay, so I'll pick for my initial one, I can pick 1.029. And then for my velocity, I'll do 0.743. Now yours should be different from mine, right? If you have the same ones, then I know that you're doing the same thing I'm doing. And then I don't want to do the acceleration because the acceleration is, I'm going to go ahead and show the velocity vector. We're doing constant velocity for this first section, so we're not going to have any acceleration. Okay, and so I'm just going to start the simulation. And I want to make sure that I stop it before I get to the very end. Okay, that's good enough. So I'm going to do 4.8 seconds as my time. My initial position was 1.029 and my final was 4.588. Okay, now I need to do my experimental displacement and my calculated displacement. So what I'm going to do for my experimental displacement is I'm going to take these two positions and take the difference between them. And I'm just going to put my calculations in this little box for these. And I'm going to get 3.559. Okay, and then my calculated displacement, I'm going to calculate that down here. Where they gave me a little spot, and I'm going to do V equals d over t, except I'm going to rearrange this equation and solve for d. So I'm going to do d equals v times t. Okay, so I'm going to have d equals v times t, which is equal to my velocity of 0.743. And my time of 4.8. I'm going to get 35664. Okay, you can see it's very similar to the other one, and that kind of makes sense. Okay, so then you're going to do the rest. Okay, you're going to use the same formula for all the trials. And for your trials, it really doesn't matter what you choose for each trial. Just pick something and just change it up each time just so it's a little different. And then you'll fill in the rest. So you'll get these 3 from the simulation, or these 4, and then you'll calculate these last 2. Okay? So then let's go to the acceleration part. Now we're going to do acceleration. So all of these are going to start from an initial position of 0. Do you see that? Okay, so I reset it. So what I'm going to do is I'm going to start my position at 0. I forgot to reset before I started it. And then I'm going to do my velocity. I'll do 0.907. And I'll leave my acceleration at 1.71. And then I'm going to start. Okay, so I have 5.1 seconds. And then my final position is 4.649. And then my experimental final velocity is 0.907. And my calculated final velocity, I'll have to figure that out. So to get my displacement, I'm going to use one of those equations, one of our acceleration equations. So I'm just going to look it up right here. Okay, so to find my experimental displacement, I can't use my v equals d over t that I used before because we have an acceleration. And so that's not going to work. Okay. So I'm going to use this first one. I hate how this says trail. Okay, I'm going to use this first equation, the df equals di plus vit plus 1/2 at squared. Okay, I'm going to do all my little subscripts. Okay, I have all of these numbers in my lab. Okay, I have my di is equal to 0, right? My vi was equal to 0.907. Oh, I just did that without accelerating it. Look at that. When I reset it, it reset my acceleration. Okay, so I'm going to clear this. I'm going to put 0.907. Start at position 0. My acceleration is 0.229. Okay. So let's start this again and see what happens. Okay, here we go. See how my velocity is going up? That's good. Okay, so I'm going to do my time is 4.2 seconds. My experimental displacement is going to be whatever that final position is, so 5.92. My final velocity is 1.879. Okay, so I have my initial displacement, that's 0. I have my initial velocity, 0.907. I have my time. I have my acceleration and my time again, so I can calculate my displacement using this formula. So I'm going to go ahead and I'm going to just do this one for you, and then you're going to do all the rest yourself. See, I'm just plugging my numbers in right now. acceleration is 0.229, and my time is 4.2 squared. Let me go ahead and make this squared before I forget. Okay, so I'm just going to do that. 0 is nothing. 0.907 times 4.2 is 3.809. And then I'm going to square my 4.2 first. And then I'm going to multiply it by my 0.229. And then multiply it by by 0.5, which is half. So I'm going to get 2.01978. I can add that to my 3.809. And my df is equal to 5.829 meters. And you can see this is a little bit different than my experimental displacement, but that's okay. It's still pretty close. Okay, and then to calculate my final velocity, I'm going to go to that same presentation that had this here, and I'm going to use my VF equals VI plus AT because that's a pretty simple equation. And then I don't have to do a lot of work. Okay, so my VF is my VI, which is 0.907, plus my acceleration, which is 0.229, and then my time, which is 4.2. Okay, so I'm going to do 2.229 times 4.2 is 0.906 or 96. So I'm going to add this. And so then I can plop that in here. Now keep in mind, if you don't show your work down here for these two columns, you're not going to get full points. Okay, I'm going to take off your points because, you know, that's kind of important. So in there, I've got it right there. And then you'll do trial 2, 3, 4, and 5. And then you'll answer the questions. Okay, so that's all you do for this lab.